They thought I was crazy when I asked the people at Chipotle to give me 3 burritos with double meat and about everything else on it except for cheese and sour cream, you know, all the good healthy stuff. And then when I asked them a fork after so that I could eat the big tray of salad that I had brought with me, and then avocado and some olive oil and some nuts and some berries. And you know what that means. We're going to tell you what we could do with all the protein in there. Because we're talking about amino acid metabolism today, you guys. Part 2, among other things. We could talk about what we could do with some of the good carbs in there, like brown rice, things like that, and some veggies and the dark leafy greens. So, you know what all that means. It's Wellness Nerd Out time! Bada bing, bada boom. What's up, Nadia? Happy Wellness Nerd Out time. Thank you for hopping on here. You guys thought we forgot about you. We sure did not. We still got 5 minutes to midnight. So, again, we are talking about amino acid metabolism part 2 today. And we're very full while doing it. But so, to pick up where we left off yesterday, we were talking about how most of the amino acids can undergo transamination, where they transfer that amino group to a keto acid, and then the keto acid becomes an amino acid, and the keto acid transfers the oxygen to the amino acid, and that amino acid becomes a new keto acid. But why does this matter? Okay, I want you to just think from scratch right now. What we're going to try to understand today, our big points, are the fact that amino acids can either make energy. They're number one, amino acids are the building blocks of proteins, as we know, right? And proteins have all sorts of functions throughout the body, and certain ones are more involved in muscle protein synthesis, like branched chain amino acids, for example, leucine, isoleucine, valine, which we've talked about, and things like that. But aside from the anabolic function and these other metabolic functions of enzymes, these protein enzymes, right? Amino acids can also be used to give us energy because they can fit into our cellular respiration story, all right? Now, they can also be used to create glucose. So this is how we're going to think of it today, again, from scratch. Here at the top, we have glucose. Glucose. It's ironic because it's really not in the heavens, as far as glucose goes. We want about as little sugar as we could get for the most part, right? Unless they're good, healthy, complex carbs, like we've talked about. And at the bottom, we have energy. So sugar, energy. Energy at the bottom, sugar. 1 hour goes this way, 1 hour goes this way. Okay? So this arrow is making sugar. This arrow is taking sugar and making energy. ATP is down here. Again, glucose or sugar is at the top. So what do those pathways sound like? Well, what happens when we go from glucose to energy? That's cellular respiration. And it begins with glycolysis. Right? We break down the sugar to the pyruvate, and there's a bunch of intermediates like we've talked about, but this is not important. We're going to get the big picture. Right? Pyruvate goes to acetyl-CoA. Acetyl-CoA goes through that citric acid cycle. We get our byproducts, our NADHs, our FADH2s, yada, 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 ATP, carbon dioxide. And then we have that electron transport chain giving us ATP at our bottom. Okay? House is 82 degrees. So, no surprise here at the wind house. So, if we have these amino acids and they're going into the cycle and they're entering at certain points, they can either be converted to energy or they can go up this way and be converted to glucose. Wait, you're telling me I can make sugar out of amino acids? I thought they made protein. Well, it depends on the environmental conditions and the demands of your body at the time. Wait, you're telling me I can take amino acids and I can get energy from them? I thought we make proteins. Well, it depends on the metabolic demands and the environmental conditions in your body at the time, right? And we try to manipulate these conditions the best we can into tricking our body to producing the right things, right? Like a white lie, kind of, right? as we wanted to produce, say, glucose instead of fat, for example. Okay? And so let's begin by saying, if we have these amino acids and they're converted into those keto acids, and we talked about alanine, aspartate, and glutamate. We talked about alanine being converted to pyruvate. We talked about acetate being, or aspartate, sorry, not acetate. We talked about aspartate being converted to oxaloacetate, and we talked about glutamate being converted to alpha ketoglutarate. Okay, so those are all, where are they? If we have glucose, pyruvate, eventually, ding, 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 there's one, alanine, boom, converted, okay? Keep going, acetyl-CoA from pyruvate, okay, nothing there. Acetyl-CoA combines with what to start the Krebs cycle? Oxaloacetate, ding, 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 that's our aspartate, boom, oxaloacetate. Goes through that cycle, and what do we have here? Alpha-ketoglutarate. What can form alpha-ketoglutarate from transamination? What's the amino acid? It's glutamate. Ding, ding, ding. So glutamate, aspartate, and we have alanine, right? So these are three of the major amino acids our body uses all the time to either make proteins, energy, or sugar. So now what happens? So all right, so why can't, all right, so does it just go, if we get them at this point, we just keep going to energy, and then any one of these points we could just go right back up the ladder to glucose up here? Well, no. There are certain steps of cellular respiration and glycolysis, right, that are irreversible. And that's why glycolysis and gluconeogenesis, right? Gluconeogenesis, new sugar production, right? New glucose production, and glycolysis, the breaking down of sugar, are not just reversible steps. The irreversible ones we'll talk about, at least one major one, is phosphoenol pyruvate or PEP being converted to pyruvate. That's one of the intermediate steps in glycolysis on our way down. PEP goes to pyruvate. Pyruvate can't go back up to PEP. So if we have alanine being converted to pyruvate, can we just go straight back up? Well, no. PEP only goes this way, right? So what are we going to have to do? How are we going to get back up eventually? Well, great question, and this is super cool, okay? So now if we want to make energy out of the amino acids, and that's what we need to do, and it goes to pyruvate, well, that's just fine. We'll just go to acetyl-CoA, combine with oxaloacetate, go through the Krebs cycle, we'll go to the electron transport chain, produce ATP. If we want energy, and that was alanine, right, going through transamination by a transaminase enzyme, right? And if we want to, if we convert aspartate to oxaloacetate and we want energy, well, we just keep going through the Krebs cycle. It just keeps going down. And the same with alpha-ketoglutarate from glutamate. We could just keep going on our road to energy. So really the only complicated thing here is how to get back up. How do we get up to glucose, right? This is the easy part, producing. How do we produce from amino acids? Well, actually what's super cool, is oxaloacetate not only can go down, but it's our key player here, oxaloacetate can go back up. And the way it goes back up, because we said pyruvate can't go back to PEP, right? It's an irreversible step on the way down. So you know what that means? On our way up, we got to skip some steps to get to the top. And one of the first ones, maybe the first one we skip, I have to review that, is oxaloacetate. The point is just what's important here. Oxaloacetate is going to skip right over to PEP, so it bypasses pyruvate. Then it goes up to glyceraldehyde 3-phosphate or G3AP. G3AP going down to PEP is a reversible thing. It goes both ways. So that's fantastic, right? And now it's easy. So when we get there, you know, there's other intermediate steps that we're not talking about, but the point's what's important. These are just kind of some of the big players here, you know. And when we get to that PEP, from oxaloacetate, we can go to glyceraldehyde 3-phosphate and then up to glucose. So really what we have to do with every keto acid that we form, whether it's pyruvate, oxaloacetate, already oxaloacetate, so we don't have to change it to oxaloacetate to go back up, right? Because that's what we're trying to get here. Or alpha-ketoglutarate, so we're talking pyruvate or alpha-ketoglutarate, which come from alanine or glutamate, right? Amino acids in transamination. How are they going to get back up if only oxaloacetate goes? Well, pyruvate gets converted to acetyl-CoA, which combines with oxaloacetate to go through the citric acid cycle, or the Krebs cycle. Eventually we have alpha-ketoglutarate. Whether it's pyruvate or alpha-ketoglutarate, they both eventually come back and can get converted into oxaloacetate, you guys. Isn't that cool? So then they get converted back into oxaloacetate, and now all three of those technically could become oxaloacetate and go back up to PET, glyceraldehyde 3-phosphate, and make sugar. So those amino acids under the right conditions will be used to make sugar or to produce energy. Now, do we prefer to take these amino acids, and do we prefer to burn them for energy when we get 4 kilocalories per gram of energy from them? Well, we get the same from glucose, and glucose is already just right in this pathway, you know? I mean, we're either gonna store the glucose, really, right, or we're gonna use it to get energy. The glucose isn't what's building our proteins, so we could use the amino acids for that. So our body really doesn't want to, but what did we say the other day, and what makes a lot of sense now? Well, shoot, if we were out of glucose when we're doing a really high intensity workout, and we have these amino acids now getting converted over to keto acids, well, they're going to be going which way? We need energy, going to be used to make energy. If you had sufficient glucose in the bloodstream getting to the muscles, sufficient glycogen stores, because we had our good carbohydrates after our workout with our protein like we should, then what? Well, if you have the sugar already, or the carbs, are we going to use amino acids to make more of it? Right? If we have it, or is the way to look at it that, you know, that sugar can now make energy, so we can use that to make more sugar? Or maybe the amino acids won't be used for either if we have sufficient carb stores. They'll just be used to build proteins. They'll be used to build proteins, right? That makes sense, because we wouldn't need them for either. We have sufficient sugar, we're getting sufficient energy. So we can use them for the purpose that we would love for them to be used for, right? That they are intended for, right? They're our last resort for energy, right? First is glucose, then is fat, you know, and then is amino acids. Now, if we had access to our fats, and we were going through beta oxidation, right? Well, we could just use the fat to get the energy, right? Before we had to delve into our amino acid stores. And that would be ideal. We would absolutely need oxygen to do that. We need oxygen to do that, right? And so, you know, if we don't have sufficient oxygen, we don't have sufficient carbohydrate stores, and we are running the risk of having to utilize our amino acids. Tomorrow we're going to talk about how glycerol, the backbone of a triglyceride, you know, our fat molecules, right? The triglyceride bound to the fatty acids. We're going to talk about how glycerol not only can be converted into dihydroxyacetone phosphate, which we had talked about previously, which is on the down arrow, right? We're going to remember our down arrow towards energy and our up towards glucose, right? So glycerol can be converted to DHAP and go down. There's also another way that glycerol can indirectly be converted to something else to go up and to make sugar. So that is pretty cool. We'll also talk about lactic acid and maybe even oxidative deamination if we have some time. But that was a little bit of a spiel today. I hope you guys got something out of it. It's about the point. It's not about the name of any of these enzymes. Just want you to realize how many different functions these amino acids can have in our body and why it's important to have proper glycogen stores and amino acid stores, especially after some high intensity exercise and during. What's up, Nadia? What up, Fabi Carlos? Cuz, what's up, Mike? And what's up, Sammy? You guys have a fantastic rest of your night, or I should say morning, because we crossed over. Happy Wellness, you guys. Have an absolutely fantastic day today, and we'll see you later on.